Hello everybody, Mr. Chan here, about to do another lesson for Algebra 2, 3-4, Dividing Polynomials. Grab your student companion note taker and turn to page 73. Here we go. Benson recalls how to divide whole numbers by solving a problem with 6 as the divisor and 83 as the dividend. He determines that the quotient is 13 with remainder 5. Let's go ahead and highlight those in this particular page. The number you're dividing with, of course, is called a divisor. Let's label that. The number you're dividing into is called the dividend. The number that you get as an answer is called the quotient. And of course, we have the remainder on the end there. In your elementary days, you might have been told or learned about long division. In this case, we are taking 83 divided by 6. When we do that, you can represent that as a fraction, 83 over 6. And once you apply 83 divided by 6 long division-wise, your answer is what we see over there on the left, the quotient 13 with the remainder 5 divided by the original divisor 6. Technically, think of it as 13 plus 5/6. Remember, 13 is the quotient now. 5, of course, is the remainder. And the 6 is the original divisor. We are actually going to apply the technique of long division from back in probably 4th grade to polynomials. Kind of crazy. Explain the process of long division using Benson's example. Okay. We kind of did that. See above. Okay, and let's take a look here. Next question, how can you express the remainder as a fraction? Fair enough. 5 over 6. And we kind of answered most of these questions already. Use the results of the division problem to write 2 expressions for 83 that include the divisor, quotient, and remainder. That's fine. We have the mixed number 13 and 5/6, literally written out like this as well earlier. Okay, question at the bottom. If the remainder in a division problem is 0, what can you say about the dividend? If we get a remainder of 0, that means the dividend and the divisor divide into each other equally. All right. Let's go ahead and apply this idea of long division to actual polynomials. Let's switch to the next page. Here we go. All right. Here we go. Example 1, use long division to divide polynomials. That sounds crazy, doesn't it? We're going to model long division with polynomials with the problem we just did. 6 was the divisor earlier, and the number was 83, the dividend. Number 1a. Use long division to divide the polynomials, in this case, x to the third minus 6x squared plus 11x minus 6 divided by x squared minus 4x plus 3. So kind of like when I set up 6 dividing into 83, we're going to do the same thing here with these polynomials. I'm going to take the dividend this part right here. And I'm going to divide by the divisor over here. And I'm going to set it up like long division that we see off to the left. Now, something you'll find out quick is you want to make sure that all the powers of each polynomial are represented. So the dividend, I see 4 terms, and all the powers seem to be there. X to the third, x squared, x to the first, and x to the 0, they're all there. The reason why I bring that up is because if any power is missing, we need something called a placeholder to kind of create a column in that long division process. Let's write down the divisor next, over here on the left. And we're ready to long divide, okay? Now, let's remind ourselves what happened with Benson and how he did long division with 6 and 83. First things first, you ask yourself, can 6 divide into 8? The answer is yes, one time. We're going to do the same thing with these polynomials. Concentrate on each polynomial's leading term. In this case, the divisor is x squared and the dividend's x cubed. Is there enough from the dividend that the divisor has to divide into? And the answer is yes. There is an x squared inside the x cube, okay? So what you do is you want to divide x squared into x cubed, and whatever is remaining is what you're going to put for your quotient, okay? So in your mind, take those leading terms of each of those polynomials and divide it in your mind. X to the third divided by x squared, okay? And when you do that in your mind, you'll get x to the first, simply because of the powers reducing like that, okay? So that x to the first goes in the quotient part, and you would write it right here. Now, I'm putting it above all the x's and it kind of line up, okay? Great. Hang in there with me. The next thing you did with that Benson did was he multiplies 6 times 1. 6 times 1 is 6. Bam. We're going to do the same exact thing with our polynomials. I'm going to take x and multiply with the divisor, x squared minus 4x plus 3, the whole thing, okay? Kind of like what I did with 1 times 6, give me 6. Here we go. X times x squared is x to the third. X times the second term, negative 4x, will give me minus 4x squared. And x times 3 is 3x. Great. Kind of like how I got 6. Going back to Benson, what do I do with the 8 and the 6? Well, in this case, I want to subtract. 8 minus 6 is 2. Great. I'm going to do the same thing over here with my polynomials. I'm going to go ahead and subtract all the terms that are like each other. Let's do it. X cubed minus x cubed, of course, goes away. That was the whole point in the first place. Watch out for the x squares, though. Be very careful. We've got negative 6x squared, yeah, minus a negative 4x squared. Now, the two negatives right there become a positive. So it becomes negative 6 plus 4. That'll give me negative 2x squared. Okay, great, great, great. I also have to subtract the third terms. We just did the first and the second already. We now need to do the 11x minus 3x particular column, okay? And as we know, 11 minus 3, of course, is 8x. So let that sink in for a minute. All we're doing is just subtracting the terms. That minus sign in parentheses is reminding us to apply negative to each of the columns. We're mentally applying that negative sign. All right. Going back to Benson, what do we do next? Well, bring down the next number in our dividend. In this case, the number 3 comes way down. I'm going to do the same thing over here with my polynomial. I'm going to bring down the minus 6. Bam. And guess what? The process starts all over again. Back to Benson's problem. I'm no longer dealing with 83. I'm now dealing with 23. Yeah, 23. The new term there is the 23 right there. I need to take care of. And oh, how many times can 6 go into 23? In this case, it's 3 times. Okay, and the process starts all over. 3 times 6 is 18. Then we're going to go ahead and subtract that. That gives me a remainder of 5. And I'm done right there, essentially. Okay, so let's go to our polynomial here. And we have a new leader. This is actually called the depressed polynomial, negative 2x squared plus 8x minus 6. Okay, so we ask ourselves in our head, hey, what times x squared will give me negative 2x squared? That's what we're doing. We're checking to see what will give me that term in the depressed polynomial, negative 2x squared plus 8x minus 6. And we only focus on the front half, right? We only focus on the front half. Another way of looking at it is to take that term and divide by x squared. And when we do that, we will get, of course, negative 2. That negative 2 goes right here in the quotient line right there. And let's go and multiply. Okay, remember 3 times 6 over there with Benson's problem. 3 times 6 is 18. We're going to do the same thing here with my polynomials. I'm going to take the negative 2 and multiply with the divisor and put it underneath that depressed polynomial. Here we go. Negative 2 times x squared is negative 2x squared. We're supposed to get the same exact thing. Negative 2 times negative 4 is positive 8x. Interesting. And negative 2 times positive 3 is negative 6. Perfect. Look at that. Once we subtract, guess what? It's going to be 0, 0. Yes! Remainder is 0. Which means that x squared minus 4x plus 3 is a factor when you have a remainder of 0. That answer is dun, 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 x minus 2. And that's your answer. Remember what we're doing. Long division is just basically factoring, breaking things down. This is a technique to take big, ugly polynomials and breaking them down into parts. And if you get a remainder of 0, that means that that particular part is divisible. It's a factor, okay? If you get a remainder other than 0, it's not a factor. But you do get an answer, like the 13 and 5/6 answer from Benson's problem from early on. Let's try another one. Here we go. We have our dividend. And we have our divisor. We have a situation where our dividend is missing a lot of powers. We have x to the 4th, but we are missing x to the 3rd, x to the 2nd, x to the 1st. And the reason why I say we're missing, because when we're doing long division, what I'm trying to say is that I'm going to need a lot of room here off to the side. Okay, we're going to need placeholders for all those powers. Okay, so right now we're missing an x to the 3rd, so you write down 0x to the 3rd. We're also missing a spot for x squared. We're missing a spot for x. And then finally our minus 85 was part of the original polynomial there. That's our dividend. Our divisor is 4x squared plus 9. All right. Ready to try this? Long division. Let's take a look at our leading terms here. We have 4x squared and 16x to the 4th. Now, you can just mentally say to yourself, hey, what times 4 will give me 16? And the answer is 4. And what times x squared will give me x to the 4th? You can also write it out and simplify it off to the side if you need to, or in your head. That's okay too. 4 goes on to 16 4 times. And x squared cancels with 2 of those x's right there, leaving with x squared right there. So my number is 4x squared. Put right there. That is what will give me my 16x to the fourth first term there. Okay, let's go and multiply. 4x squared, the quotient, with 4x squared plus 9. Here we go. Multiply. Oh, we have a plus 9 on the end there, times 4x squared is 36x squared. I'm going to put it right there. All right. Next step, subtract. All those columns, 16x to the fourth minus itself goes away, of course. That was the whole point in the first place. And watch out for that x squared. 0 minus 36 is negative 36x squared. And the process starts all over again. Let's bring down the next term. In this case, is negative 85. Bring that down. And let's walk through this again, okay? We now have negative 36x squared divided by 4x squared. Those are the terms in front right there. And when I reduce that in my head, I'll get negative 9. Look at that. And 4 goes to negative 36, negative 9 times. And let's multiply that part of the quotient with the divisor. All right, here we go. Negative 9 times 4x squared is negative 36x squared. And negative 9 times positive 9 is minus 81. Let's go and subtract those. All right. Negative 36 minus negative 36 goes away. Oh, 85 and 81, be careful here. We have negative 85 minus a negative 81. Negative 85 minus negative 81 will give you a plus 81 because of the double negatives, which means my remainder is negative 4. Woo! So ladies and gentlemen, 4x squared plus 9 is not a perfect factor of the original polynomial 16x to the fourth minus 85 because we have a remainder, okay? It doesn't divide into it equally, all right? So in this case, you would write as an answer, follow this, take the quotient, write it here, and tack on the remainder. The remainder in this case is negative 4 over the original divisor, 4x squared plus 9. Isn't that fascinating? This is the answer to that problem right there, okay? All right, take a moment, let that sink in for a moment. Maybe take a little break or something. All right. Ooh, any questions? All right, that takes care of something called long division. All right, let's move on to example 2, to another type of division called synthetic division. Sometimes dividing polynomials by long division takes a lot of work. There's actually a faster way for polynomials whose divisor is in the form of x minus a. If you have a divisor in that form, x minus a, then you can do something called synthetic division. Guys, ready to follow along here? Synthetic division is kind of like taking the coefficients of the divisor and the dividend and keeping it into a very organized and tight kind of a pattern. Okay, here we go. We're doing the same exact thing. We're dividing polynomials, but using a different technique. Because right now, in example 2, it says, use synthetic division to divide 3x cubed minus 5x plus 10 by x minus a. A is the root that you might recall when it comes to graphs that cross the x-axis. A root is also known as the x-intercept, the solution, or also known as a zero. Not only do polynomials have roots, all kinds of graphs have roots, depending on the shape. They eventually cross the x-axis, most of them, right? Sometimes you have ones that float above or below the x-axis and they don't have roots. So when we have the divisor of x minus a, we can use something called synthetic division. Take a look at our dividend right now. And take a look at our divisor. What I'm going to do is draw like an L, like that. I'm going to pluck the coefficients from the dividend and put it inside the L. Here they are. 3, 0, -5, and 10. Now you see where the 3 comes from. It's in front of the largest term there. The 0 comes from a missing x squared. The -5, of course, is right there for my next coefficient, and the 10 is the last coefficient or constant. So you got to put them all there. It's kind of like long division. Those are all representing the powers. Next, we got to deal with the divisor, okay? The divisor is x minus 1. Take the value of a from there. A is opposite of -1, it's +1. Remember, your original is x minus a. The minus sign is built into the actual factor there. Think opposite. So the 1 goes over here on the left side of the L. Okay? All right. So now we're ready to do something called synthetic divide, and it's actually very straightforward. Here are the rules. Step 1, add vertically. Step 2, multiply diagonally. And that's it. Those are the 2 rules. Add vertically. This is a visual aid here. And step 2, multiply diagonally. The plus sign has a vertical line, and the multiplication symbol has a diagonal line. So that's a great way to memorize that. Add vertically, multiply diagonally. Okay? So what are we talking about here? So step 1, add vertically. So take the first coefficient and add vertically. Bring it down. We're going to add the 3 just straight down. That goes down to here. Bam. Step 2, multiply diagonally with the a value. So I'm going to multiply 1 times 3 right there. 1 times 3 is 3. So recap. Add vertically, we added the first coefficient, got a 3, brought it down. Step 2, multiply diagonally with the root value. A is 1. So 1 times 3 is 3. Take that value and put it right here. Take your answer and put it right there. And start all over with the second column. Add vertically, 0 plus 3 is 3. Multiply. 1 times 3 is 3. And then bring that answer up into the next column, like that. Okay? This is very strange, isn't it? But it's kind of like long division, but without variables. Add. -5 plus 3 is -2. Multiply. 1 times -2 is -2. Put it right here. Okay, how are we doing? Last column, add. And you don't really multiply, but 10 plus -2 is +8. That, ladies and gentlemen, is your remainder. So how do we represent the answer the answer has to be put back into with polynomial variables, okay? So we just got the remainder of 8. Read backwards those numbers that we got when we added vertically. 3, 3, negative 2. Going backwards from right to left, I want you to think of it as the number next to 8 is the constant. I'll use C. The number to the left of that is the first power. And the next number to that to the left is the second power, and so on. So you're building your polynomial based off going backwards from the remainder going left. So your final answer is, brace yourself, 3x squared plus 3x minus 2, the constant, plus the remainder divided by the original divisor, x minus 1. This is faster than long division if your divisor is an x minus a form. It's really cool. Any questions? Okay, let that sink in, pause the video, maybe rewind it a little bit and walk through that again. We're going to do another one that allows us to use synthetic division. I'm going to use the one in the book. Here we go. 2x cubed minus 7x squared minus 4. We're going to divide that by x minus 3. Yay! That is x minus a. So my a in this case is positive 3. This qualifies for synthetic division. Let's draw our L. And in this case, I'm going to put the coefficients here. We have a 2 for x cubed. We have a negative 7 for x squared. We are missing an x, aren't we? So we've got to put it 0 for x as a placeholder. And negative 4 is a constant. Place your a value 3 off to the left. And remember the rules are add vertically, multiply diagonally. Okay, here we go. Column 1, add vertically. Boom. Bring the 2 down. Great. Multiply diagonally, step 2. 3 times 2 is 6. Bring that into the second column. Start all over. Add vertically. And you can pick up the speed here, definitely. I'm just taking my time. Negative 7 plus 6 is negative 1. Put that number right here. And multiply. 3 times negative 1 is negative 3. Add the third column numbers. 0 times negative 3, plus negative 3 is negative 3. And multiply the a value with that sum. 3 times negative 3 is negative 9. Put in the last column right there, and then add vertically. Negative 4 plus negative 9 is negative 13. And ladies and gentlemen, the last column is your remainder. Then let's go to the left and build up my polynomial, starting with the constant, the first power of x, and the second power of x like that. And that gives me my final answer. 2x squared minus 1x minus 3 plus negative 13 over the original divisor, x minus 3. Yes, x minus 3 is not a perfect factor because we have a remainder. Make sense? If it was a 0, that would be perfect, wouldn't it? All right. So what I want to say is pause the video, let that sink in, and for the rest of the lesson, I want to throw a couple of theorems at you, which sound very fancy, but I've already told you most of the theorems with the problems themselves. Hey, if you divide a number into another number and you get a remainder of 0, that means it is a factor, yeah? And if you want to figure out another cool thing, it's called the remainder theorem. Here we go. I'll throw a couple of theorems at you that are very big in algebra. One's called the remainder theorem. If your function, call it p of x, is divided by x minus a, then the remainder is the function throwing the a value into it. This is very powerful. You don't have to go through long division or synthetic division. You can actually get the actual value, the remainder itself, by plugging in the a value into the function. So the key here is to substitute the a value into the polynomial function. The remainder theorem is very, very powerful. The factor theorem's next. We'll do something with the remainder theorem in a moment, don't worry. The factor theorem says this: if, oh, I'm sorry, I shouldn't say if. I meant to say, the expression x minus a is a factor of the polynomial p of x, if and only if your remainder theorem gives you an answer of 0. Okay, it is a factor if and only if the remainder is 0. That's all it's. I've already mentioned that a few moments ago, right? Remainder is 0. Oh yeah, forgot to mention that. That means if and only if. All right. Any questions? So we have a little habits of mind there that says, hey, which method would you use to divide a polynomial by x squared plus 5? Now, x squared plus 5 is not in the form of x minus a. So that means you must use long division, but not synthetic division. Because it's not x minus a. All right. All right, let's try number 3 here. Relate the function throwing in the root value a to the remainder of p of x divided by x minus a. Use synthetic division to show that the remainder of that function divided by x plus 2 is equal to the function -2. Very cool. Okay. So what I'm going to do first is the second half of this question. I'm going to actually focus in on finding f of -2. Okay? F of -2. Basically, they want us to replace x with -2 from the function. Here we go. The function is x cubed plus 8x squared plus 12x plus 5. I'm going to put in the -2. Okay. Put it there, there, there. Okay. I'm going to show you the remainder theorem here. Really cool. -2 to the third, let's clean that up, is -2 times -2 times -2 is -8. Over here after next, we have 8 times -2 squared is +4. And then 12 times -2 is -24. And we have 5, okay? Let's clean it up further. That's -8 plus 32 minus 24 plus 5. This equals to, what is that? 24 minus 24 plus 5. Aha, that equals to 5. Ladies and gentlemen, when you plug in -2 into this polynomial, you'll get +5. That means that's a coordinate point. Okay, we're going to now do synthetic division and see what we get there separately. Here we go. Draw your L. Write down the leading coefficients: 1 for x cubed, 8 for x squared, 12 for x, and 5 the constant. My divisor is x plus 2. A has to be opposite of plus 2. In this case, is minus 2. Think about it. X minus minus 2 will give you back your x plus 2. Therefore, A is backwards with the negative 2. Put the negative 2 over here. The rule, of course, is to add vertically and multiply diagonally. Let's do it. Here we go. Add the first column. That gives me 1. Multiply the A value with the sum there. Negative 2 times 1 is negative 2. Put it into the second column. Okay, start all over. Add. 8 plus negative 2 is positive 6. Multiply. Negative 2 times 6 is negative 12. Put that over here. Interesting. Add. 12 plus negative 2 is 0. Multiply. Negative 2 times 0 is 0. Put it into the last column. And then add for your last step there. Aha. We have a remainder of 5? That looks familiar. In fact, there it is. Synthetic division can give you the function value quicker than actually plugging in manually. Plugging in numbers in manually that we did a few moments ago takes a lot of work. Synthetic does it very, very fast. All right, so there it is. We just showed that they're equal. Next page. Again, ask questions, pause the video, whatever. Very interesting, isn't it? A technology company, number 4 on the next page, uses the function r of x equals to negative x cubed plus 12x squared plus 6x plus 80 to model expected annual revenue in thousands of dollars for a new product where x is the number of years after the product is released. Use a remainder theorem to estimate the revenue in 5 years. So I can, if I never knew all this stuff, I just plug in the number 5. That's all I'm doing. Plug in the number 5 in for x. But that takes a lot of work. Could I do it faster? The answer is yes, using the remainder theorem. That's really cool. Just use synthetic division. Add vertically, multiply diagonally. Very cool. Let's draw our L. Take a look at the leading coefficients here. Negative 1, 12, 6. I don't need any placeholders, 80. The number 5 is already A. This is already A now. They don't give us a divisor x minus a form. This is already A. Okay, that goes right there. You don't have to make opposites because they're not giving us a binomial here. They're giving us the actual number to plug in, the root to check. Plug in the 5. Here we go. Add vertically. Multiply diagonally. Five times negative 1 is negative 5. Add vertically. 12 plus negative 5 is 7. Positive 7. Whoops. Did I say negative 7? And multiply. When you multiply 5 times 7, I got 35. Put that into the next spot there. Add vertically. I get 41. Multiply diagonally. 5 times 41 is 205. And then add. This is a quick way of getting function values using synthetic division. Isn't that strange? It's very cool. And there's your answer, 285. And this revenue is in thousands, so my final answer is $285,000. Yay! All right, let's move on to number 5. Any questions about number 4? All right, we're going to use the factor theorem. Use the remainder and factor theorems to determine whether the given binomial is a factor. The key here isn't divide into the polynomial evenly. When we say divides into the polynomial evenly, we expect the remainder to be 0. That's all we're doing. That's the check. That's it. We're going to do synthetic division. Here we go. 1, -10, 28, -16. My divisor, x minus 4, a is +4. Put it right there. Add vertically, multiply diagonally. Very cool. I'm going to do less writing with the arrows. Here we go. Please be patient. Add the first column. 1, multiply, add, multiply, add, multiply. Bingo. I hope I didn't go too fast there. I kind of left out all the arrows there. Add vertically, multiply, add, multiply, add, multiply. And my remainder is 0. Yay. Woohoo. So the factor theorem says, if you get a 0, the divisor, x minus 4, is a factor. So that means x minus 4 is a factor of the polynomial p of x, because p of 4 equals 0. Yay. It's a check. All right, let's do another one. 5b. Let's see, we don't need any placeholders. Put your leading coefficients here, 2, 9, -2, 6, -40. Our divisor is x plus 5, which means my a value is -5. Put that over here off to the left there. Add vertically, multiply diagonally. Let's do it. Here we go. 2, -10, -1, +5, 3, -15, -9, +45. Bam. Sad face. My remainder is 5. Which means x plus 5 is not a factor of p of x. Womp, 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 womp. All right. Habits of mind. Is x minus 2 a factor of that long polynomial? If not, what is the remainder? Okay, they're just asking the same question, just asked a little differently. Let's go ahead and do this. My x minus 2 is in that form of x minus a, and a in this case is +2. Thinking backwards there, let's draw our L. Bring down the leading coefficients. Put the 2 off to the side here. Add vertically, multiply diagonally. Here we go. Add. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. Just double check everything here. Multiply, add. Oh, so close. Womp, 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 womp. The answer is no. X minus 2 is not a factor. But the remainder is 1. Yay. All right. I think we're ready for the last page. This is weird, isn't it? Long division, synthetic division, very strange. Last page, here we go. They specifically tell us to use long division. Let's do that. Let's check the dividend, make sure we have all the powers here. Yep, that looks pretty good there. We're going to go ahead and do this. In fact, if you get a little lazy, look what I'm doing there. Ha 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 ha. And then I'll put my divisor off to the left of the dividend. Kind of lazy there, isn't it? All right, here we go. Let's check the first terms. X squared and, oh, Very funny, Mr. Chan. Very, very funny. Thought I was saving some time here. Let's put it right here. What am I thinking? I thought I was saving myself some room. I don't have enough room up there to squeeze that into my division symbol. So I'm going to do it this way. Okay, no big deal. All right, here we go. So look at the first terms of each polynomial and ask yourself, hey, what times x squared will give me x to the fourth? Or simply in your mind, think of, hey, what's x to the fourth? Divide by x squared. In this case, we'll get x squared. Yeah? Boom. And I'll put that x squared right here. Next step, multiply the quotient x squared with the divisor x squared minus 8. Here we go. X squared times x squared is x to the fourth. X squared times negative 8 is minus 8x squared. Notice I'm lining up the powers up. Next step, subtract. Okay, x to the fourth minus x to the fourth goes away. That's the whole point in the first place. Watch for the third power here. This is kind of interesting. Negative 4x to the third minus nothing is, you got to bring that down. Negative 4x to the third, like that. The next column, 12 minus 8 is 12 plus 8. Don't forget those double negatives. 12 plus 8 is 20x squared. Okay. Bring down the next term and start all over. We're now going to take negative 4x to the third, divide by x squared, and see what happens. All right, x squared goes into x to the third, 1, remainder 1 left. That gives me negative 4x to the first. Let's put that up here, negative 4x right there. And let's go and multiply negative 4x with the divisor, x squared minus 8. Negative 4x times negative, positive 4x squared is negative 4x cubed. That's the whole point, make it go away. And then the second half is negative 4x times negative 8 is positive 32x. Subtract. Okay, first columns go away, of course. We have the 20x by itself, bring that down, because that minus nothing is still the same. And then the last column, negative 3 minus 32 is negative 35. X. And let's bring down the next term in my polynomial from the dividend and start all over. 20x squared. Okay. Divided by x squared. Ooh. Let me see, plus 20, I want to double check everything. Uh-oh. Oh my goodness. You guys notice something crazy? I misread the divisor as x squared plus 8. That's okay, no big deal. In my notes on my website, it's x squared plus 8. Let's just change that, yeah? Everyone, let's do that, because I've already gone this far. So let's just change that to x squared minus 8. I was wondering why my answer looks a little different. No big deal. I just copied down the problem wrong. Forgive me. We're just going to keep going here, okay? It doesn't matter. We're just practicing something called long division. Whatever the answer is, not a big deal. I'll give the answer to the other one as well, and you can find that on my website. How silly of me, okay? All right. I was wondering why it looked kind of weird. All right. So 20x squared divided by x squared is 20. Apologize for that. And I'm going to put right here, plus 20, and multiply. Embarrassing. Whoops. And 20 times negative 8 is minus 160. And subtract. The answer is typically ugly in these cases. Negative 35x. And watch out here. 6 minus 160 is plus 166. And that's it. We're done. That's your remainder. So the final answer is the quotient, x squared minus 4x plus 20, plus the remainder, negative 35x plus 166, divided by the original divisor, x squared minus 8. This is the answer that we got for a problem we just did where I made a mistake with the divisor early on. In the book, your actual note taker, the answer is x squared minus 4x plus 20, sorry, plus 4, plus 29x minus 26 divided by x squared plus 8. That's if this is in the book, in the note taker. Sorry about that. Notice that the divisor is correct. My answer is correct if I use the divisor of x squared minus 8. But the point is to practice, yeah? All right, take a look at this. A lot of work, huh? Long division. My favorite, of course, is synthetic. Example 5. Here we go. Yay! Let's draw our L. We have 1, negative 8, 9, negative 5, and my x minus a term, my a value is positive 3. Put that over there on the left. Okay. Add vertically, multiply diagonally. That's the key here. Add, multiply. Here we go. Bring down the first term. Multiply. Add, multiply, add, multiply, add. Negative 5 plus negative 18 is negative 23. Ladies and gentlemen, that is my remainder. And then I'm going to reproduce the actual polynomial, the depressed polynomial, go from left to right. So the remainder, constant x, x squared, and that'll give me my final polynomial, which is the quotient of 1x squared minus 5x minus 6 plus my remainder over my original divisor x minus 3. Yay. Whew, long section. Let's go on. Any questions about number 5? Number 6, use the remainder theorem to find the remainder of 2x to the 4th plus x squared minus 10x minus 1 divided by x plus 2. So here we are just going to use synthetic division. We will need a placeholder for x to the 3rd. So here we go. 2, 0, 1, negative 10, negative 1 are my coefficients. Great. My a value looks like, if you compare it to x minus a, negative 2. Great. Put negative 2 right here on the left. And let's do it. Add vertically, multiply diagonally. Here we go. Add, multiply, add, multiply, add, multiply, add, multiply, add. That's your answer. 55. All right. Woo. Ready for the last problem of the day? Here we go. Hey, is x plus 9 a factor of that polynomial? If so, write the polynomial as a product of two factors. If not, explain how you know. Well, x plus 9 is definitely x minus a. A is negative 9. Let's test it using synthetic division. 1, 11, 15, negative 27. I don't need any placeholders. Let's put the negative 9 right here. And the key, of course, is to add vertically, multiply diagonally. Here we go. Add, multiply, add, multiply, add, multiply. What? That is great. My remainder is 0, which means x plus 9 is a factor. And that factor is x squared plus 2x minus 3 times my original divisor of x plus 9. Now they want us to leave the answer like that. But you know that this depressed polynomial is something that you can actually break down even further. Yeah, crazy. Remember, we're breaking pieces into pieces. X squared plus 2x minus 3 can be done in your head. There it is. Yeah. All right. Either one of them are correct, but they wanted this one, of course, but it can be factored further. If there aren't any questions, I hope you guys have a good day. Thank you very much. Talk to you later. Bye-bye.